Hello everyone. In today's lecture, we will start with the topic exhaust gas regulation control. It is again one of the most important parameter when we talk about the electronic engine system, and when we are using an electronic engine control system in any of the automobile. So a second electronic engine control subsystem involves the control of exhaust gas. It is important to control the exhaust gas because uh, if sensors gives a correct input, then this exhaust gas can be recirculated back and reused by the intake manifold. When normal operating condition persist, that time engine cylinder temperature can reach a point at which NOx is formed during combustion. The exhaust generally have NOx emission that increase because of the increasing combustion temperature. Thus, a small amount of exhaust is introduced into the cylinder to replace some of the normal intake air. This results in lower combustion temperatures, which reduces NOx emission. That means when we are recirculating the gas back to the intake manifold, that time it reduces the temperature of the combustion chamber, that means cylinder, and when the temperature reduces, that automatically reduce the emission of NOx. The control mode selection logic determines whether EGR is turned off or on. That means when we have a controlled algorithm which is run in parallel to the inputs taken from the sensor and various decision given to the actuators, based upon it the EGR is turned on and off. EGR is turned off during cranking because at cranking we need that a higher temperature should be attained. Cold engine temperature, that means when engine is warming up, that means again we need that temperature should reach higher. That means higher fuel air fuel ratio is to be allowed. Idling, acceleration, or other condition demanding high torque. Since exhaust gas recirculation was first introduced as a concept for reducing NOx exhaust emissions, its implementation has gone through considerable change. Because first our criteria was that we are doing exhaust gas recirculation just to reduce NOx emission. But now with the change in technology, we have changed the method to implement this EGR control technology. Fundamental to all kind of the EGR technology is a passageway or a port that connects the exhaust manifold to the intake manifold. For the proper functioning of this connecting or the passageway, a valve is positioned there whose position regulates the EGR from 0 to some maximum value. That means this valve is signal operated, electronically operated. In one configuration, the valve is operated by a diaphragm connected to some kind of variable vacuum source. The controller operates a solenoid in a periodic variable duty cycle mode. That means which cycle is going on, as per that signal is generated to a solenoid. Based upon that, this diaphragm valve actuate. By varying this duty cycle, the control system has proportional control over the EGR valve opening and thereby over the amount of EGR also. However, this EGR, electronic gas recirculation activation, can also be done using a motor. such as a stepper motor. But that means various kind of actuators we can use. It can be a diaphragm based actuator, it can be a solenoid based actuator, or it can be a stepper motor. Solenoid based EGR actuator is always have cost advantage over the motor based. Although manifold vacuum required to operate, it varies with engine operating condition and is very slow at wide open throttle. So that means the solenoid response slow as per the condition, engine operating condition keep on varying with time. In many EGR control system, the controller monitors the differential pressure between the exhaust and intake manifold via differential pressure sensor. With signal from this sensor, the controller can actuate the valve opening for a desired EGR level. So basically what we are using is the differential pressure sensor as an input to operate a valve for the EGR control. The amount of EGR required is predetermined function of the load on the engine. That means how much power is required to be produced by the engine, that determine the amount of EGR. So a simplified block diagram is given here, where you can see that there is a intake air valve going to the engine, then it has some exhaust gases, then along with those exhaust gases, electronic gas recirculation valve is attached. So along with this connection, exhaust gas are going where EGR valve is attached, and this EGR valve is further connected with the differential pressure sensor. Now how the working is, DPS sensor provides signal of the pressure at the exhaust manifold and the input manifold and gives signals to the engine controller. Based upon the pressure difference achieved signal by the engine controller, it gives command to the EGR controller. Based upon the EGR controller algorithm, it compares the input and gives the control signal to the EGR valve for the open and closing. When it's open, then the exhaust gas as a feedback goes to the intake air and again enter to the engine. The EGR valve is operated by a solenoid regulated vacuum actuator coming from the intake. The engine controller determines the required amount of EGR based on the engine operating condition and signal from the differential pressure sensor between the intake and exhaust manifold. The same thing which I have just discussed about the block diagram. The controller then commands the correct EGR valve position to achieve the desired amount of EGR via variable duty cycle actuator signal. The optimum amount of EGR can be determined empirically as a function of engine operating condition. So these are the algorithm which use some empirical formula, and these are able to determine the optimum amount of EGR based upon as a function of the engine operating condition. So that engine operating condition can be a temperature or pressure. Ideally, closed loop control of this EGR would require, for example, combustion temperature sensor. Although a cost-effective sensor for directly measuring combustion temperature has not been developed yet, there is a correlation between exhaust gas temperature and the combustion temperature. So we are using that if the combustion temperature has reached this much value, then we determine that with the help of the exhaust gas temperature. So exhaust gas temperature is calibrated in terms of the combustion temperature. In principle, the amount of EGR could be based upon a closed loop control system where using exhaust gas temperature measurement for a feedback signal. That's all about this unit, and as I have given unit number 6 some topics in the assignment, and still one more class is left. I'll give you the introduction about the unit number 6, but most of the topics we have covered in the assignment submission, and as I have discussed with you that you have no queries related to that because the topics are really very easy, related to power steering, related to the anti-lock braking system and so on. Might you'll be able to complete the assignment and understand the topics well. Thank you.